so onto the maths now. The first topic we're going to be looking at is trig. I think a lot of people, I guess, like trig. I think that's probably because like you start looking at trig like pretty early in high school. And like you just sort of slowly builds up on your trig until you can get to the point where you can do like your year 12 trig questions. Trig does make up like a fair few bit of your paper, so you do want to be super familiar with it. Okay, so just a quick, I guess, little side note. These questions that we look at will have a little bit of a difficulty rating on the side. I have tried to include mostly what I would consider like a difficulty level of 3, just so you guys are exposed to like the harder questions, because I think a lot of people focus on the easier questions when they're studying. So I thought let's look at the harder ones today. And then with each of them, just looking at a little like what syllabus point, I guess, relates to that question. Okay, so this question is from the 2018 HSC paper, so it's question 15. And the syllabus point it's most relevant to you guys is use trigonometric functions of the form k multiplied by f of a times x plus b plus c to model and or solve practical problems involving periodic phenomena. Super, super, super common question to get. And they always, not always, but really commonly, these questions come up as sunrise to sunset or tides, like the tide of water going up and down. A super common question type to see, so super important that you guys know how to do this one. Okay, so the length of daylight, which is the function L of t, is defined as the number of hours from sunrise to sunset and can be modeled by the equation L of t is equal to 12 plus 2 cos all on 2 pi t over 366, right? So with that, t is the number of days after the 21st of December 2015. For 0 is less than or equal to t, which is less than or equal to 366, right? So I'm just going to give you guys a second to like read that again to yourselves. Okay, so then we've got part I, which is find the length of daylight on the 21st of December 2015. So for right now, we're just going to look at part I. That's the only part we really care about right now. So let's think about finding the length of daylight on the 21st of December 2015. So 2015, December 21, is our start date. So at that date, t is equal to 0. So what we're finding is L of 0. So then what we want to do is just plug that into our equation. Right, so if we put t into our equation, this is what we're going to get. And so we're going to get 12 plus 2 cos 0, because this little bit here will equal 0, because when we're multiplying anything by 0, we're going to get 0. So our numerator will be 0, which will make our whole fraction equal to 0. So then we've got equals 12 plus 2 times 1, which is equal to 12 plus 2, which is equal to 14. So therefore, the day is 14 hours long. Right, and that's all we need to do to get part I. Right, so with this one, we just need to make sure we're identifying if it's the 21st of December, our variable in this situation is t. So on this date, what is t going to equal? And it says we know that 21st of December is our start date, so t is equal to 0. Okay, so then we want to be looking at, for part II, what is the shortest length of daylight? Okay, so I'm just going to give you guys all maybe 10 or so seconds just to think about how we might be approaching that question. Okay, so when we're looking at what the shortest length of daylight is, we're thinking about being between 1 and -1, right? When we're thinking about our shortest length of daylight impacting our amplitude, okay? So if we didn't have this 2 here, our amplitude, so like how our graph's going up, how tall it's going up, how short it's going down, is just 1 to -1, just based on our basic cos graph, right? But let me erase that. But because we do have 2, we need to be thinking about how that's going to impact our amplitude, right? So if we just had this without the 2, this is how we would be looking at finding the shortest length of daylight, because our shortest length of daylight is going to happen at the lowest point on our graph, right? So if we didn't have that 2, this is what we would be looking at. Now, similar to how you would change your domain and range when you're looking at your trig functions, like solving for a trig function, that's what we need to do to this, right? So what we want to do is have 2 cos 2 pi t 366 in the middle of this notation for our domain, right? And so what we've done to the middle is times it by 2, right? To get from here to here, we've times it by 2. So we're going to do the exact same thing to either side. And we're going to get -2 to 2. Right? So that's thinking about our amplitude. So we got to then think about which side is going to give us the shortest length of daylight. Right? And then when you think about that, -2 equals 2 cos 2 pi t on 366 will give us the shortest length of daylight. Right? Because -2 will be our low point. Right? And our lowest point is where we're going to find the shortest length of daylight. So then the next thing we want to think about, just quickly change color, is then solving, right? We want to solve for 2 cos 2 pi t on 366 is going to give us -2, right? So what we want to do is we've got our equation, which is L of t is equal to 12 minus, well, let me check if it's minus or plus 2 cos 2 pi t on 366. And then we've just said when 2 cos 2 pi t on 366 is equal to -2, that's when we're going to get our shortest length of daylight. So then what we're going to do is then sub in what we've said is going to be here, which is our -2. So we're going to get 12 equals -2. Oh, sorry, 12 equals 12 minus 2, which is then equal to 10 hours. So we say, therefore, our shortest length of daylight is 10 hours. Right, so with these questions, when they're asking about what is the shortest length of daylight, they're asking for like an actual thing, you do want to be giving, I guess, not really a sentence, but like a worded at the end, you know, like, therefore the day is 14 hours long, or like, therefore the shortest length of daylight is 10 hours, and actually write that out rather than leaving it here. So yeah, that's all we needed to do for part 2. I think sometimes people get a little bit confused with these sorts of questions with not realizing that you can sub this in up here, and then like all of a sudden they're trying to like solve this for t, but we're not finding what day is it going to be the shortest length of daylight, right? So if we were finding what day, then that's when we'd want to solve for t, but we're not. We're trying to find what is the length of daylight when it's the shortest, right? So this is when it becomes really important again to think about your variables and to understand what each of your variables means, because in this situation, if you know you're not going to solve for t, you won't make the mistake of getting here and then trying to solve that. Okay, so then that's part 1 and part 2 done. And then we've got, what are the two values for t for which the length of daylight is 11? So again, I'm just going to give you guys a couple seconds to think about that. Okay, so, oh good, I was worried I didn't put a slide in to answer this question, but I did, so we're good. Okay, so when we're thinking about this sort of question, well, let me get back. This is when we are solving for t, right? So we understand that the variable we are most interested in right now is t, okay? And we're looking at for which the length of daylight is going to be 11. Okay, so they've given us that LT is going to equal 11 in this situation. And we want to solve for t. Okay, and so this is the sort of question when we're now thinking about our trigonometric function itself and how we can go about solving that. So I'm just going to change colour so you guys can see it. So this is when we go 11, which is the LT that they've given us, is going to equal 12 minus 2 cos 2 pi t on 366. Let me just check that I wrote that down right. Again, this is when we come into checking, making sure you're writing down the right thing. 12 plus 2 cos pi. Okay, cool. Oh, no, I didn't do it right. That's plus, not a minus. Okay, and so then this is where we are now trying to solve for t, okay? First thing we want to do is minus this 12 across. So we do minus 12 on both sides, and we're going to get minus 1 is equal to 2 cos 2 pi t on 366, right? And then another easy thing that we can do is to take this 2 across, divide it, so then we're going to get negative 1/2 is equal to cos of 2 pi t on 366. Now, this is when you get the negative 1/2 and you're thinking about, okay, like I know that there's going to be one of our exact ratios here because we've got 1/2, right? So I want everyone to think about in their heads, or if you've got a formula sheet with you, it's on your formula sheet, that exact value triangle, and think about what is going to be the value of cos when it's equal to negative 1/2. Then you're going to have to think about the all stations to central, that little diagram. I'll actually just draw one down for you. Stations to central. Okay, so if we've got cos is equal to negative 1/2, then we're going to be able to say that 2 pi t on 366 is equal to 2 pi on 3 or 4 pi on 3. Super, super important you remember that it could equal either of these things because there are two quadrants in which cos is going to be negative. Okay, so important that you guys remember that cos is going to be negative here and here. Because if you only remember one of those angles, you're going to end up with only one answer. But the question, we've got to remember, the question is asking us, what are the two values of t, for which the length of daylight is 11? That 2 is also an indicator that you don't have to keep going round and round and round and round and round. They only want you to do the first 2. Okay? So then we want to solve for each of these. So if we've got 2 pi t on 366 is equal to 2 pi on 3, then we can pretty much go, okay, We can cross these out on both sides. And then what do we want to do? Then we can go t is going to equal 366 on 3 if we move all those around properly, because we're going to multiply that 366 across. So then that's why we're going to get 366 on top, and the 3 is still in the denominator. And then if you work that out, 366 divided by 3 is 122. That's a whole number, so that's pretty good. 122 days. Remember, this is when we're thinking about what is our solution going to look like. 122 days after, December 21. And then we're going to do the same thing with our second solution. And then we're going to get 4 pi on 3. And then with this one, we can cross our pi's out on both sides. Then we're going to do t is equal to 2 times 366 on 3. Okay, and then if we work that out, we'll just use a calculator really quick. Then we're going to get 244 days. Okay, and then we've got, I'm just going to write this one more thing. Therefore, t will equal 122, or 244. Okay, and then that's how we solve for part I. Okay, so this is a difficult question, but it's also the sort of question that, like, if you see it enough times, like just using different values, you do get super used to answering them. Super common trig question that all of you guys should be familiar with. Okay, so this one's a little bit easier, I think. So this one I would say is probably like a 2 out of 3 difficulty. And we're looking at the syllabus point. Use trigonometric functions of the form k times f of a x plus b plus c to model and or solve practical problems involving periodic phenomena. Okay, and this question is just find all solutions of 2 sine squared x plus cos x minus 2 equals 0, and the domain 0 x is between 2 pi and 0. So I'm just going to give you guys all just 20 seconds just to think about this. Yeah. Alrighty, well, we'll just look at this. I actually might just write the solution underneath this so we can still see the question. Okay, so with this, we are trying to solve, but what we were trying to do, we need to find something to solve for, right? We want this all to be in terms of just one variable, because we don't know how to solve for x if we've got sine squared and cos. We want it to be just sine or just cos. So the first thing we want to think about is how can we change one of these to be like the other one, right? So this is something super important about manipulating one of the formulas on your formula sheet. And this will be the hardest part of the question, is doing this first step. So hopefully you guys are all familiar with the formula. Sine squared x plus cos squared x is equal to 1. Right? So from that, we can then say that sine squared x is equal to 1 minus cos squared x. Funny how that works when we've got sine squared x as one of our parts of the question, right? So then that's when we can then, just do this in a different color, we can then say, okay, that equation is equal to 1 minus cos squared x plus cos squared x minus 2. not cos squared x, just cos x. Sorry. Got a bit carried away. Oh, I just wrote it wrong too. Okay. I'm not doing so great on this question so far. Cos squared x minus 2 is equal to 0, right? And now all of a sudden we've got our variables in terms of one another, right? We want only one trigonometric function. Okay, so then if we expand that to minus 2 cos squared x plus cos x minus 2 equals 0. And then these will cancel each other out. And then we get minus 2 cos squared x plus cos x is equal to 0. Okay, super important that you don't make the mistake of trying to add this into this, because they're not like terms, right? Cos squared is not the same as cos x, right? Just like if we had x squared plus x, we couldn't add those together, right? So super important you don't fall for that common, I guess, like mistake that people make, right? Okay, so then what we want to do is think about how can we find something that we can then use to get an angle, right? Whenever we're looking at questions solving trig functions, we're thinking about how can we find an angle in terms of our or stations to central, right? So then, just like you would do if I gave you, I'll just quickly write this in different colors so you don't get confused, minus 2x squared plus x, just like you'd factorize that, we're going to factorize this expression here. Okay, so we're thinking about, okay, what's going to be common? And common between them is cos x. I'm actually going to flip these around so we've got this term first, just so we don't have a negative at the front. So cos x times 1 will give us this cos x down here, and then cos x times minus 2 cos x is going to give us minus 2 cos squared x, okay? And then from here, we can then have two solutions, just like we would have if you did this with x's. You'd then get cos x equals 0, or you'd get 1 minus 2 cos x is equal to 0, right? Because if we're multiplying these two terms together and they're giving us 0, at least one of our terms has to equal 0. Okay, so if we've got cos x equals 0, then we know that our x is going to be pi on 2 or 3 pi on 2. Okay, and then if we've got 1 minus 2 cos x, we need to do a little bit more manipulation to that. So we're going to get minus 2 cos x is equal to minus 1. So then cos x is equal to a half. And then if we've got cos x is equal to a half, we can then, again, thinking about our exact value triangles, think about x is equal to pi on 3 or 5 pi on 3. Again, with this question, super important to remember that there's more than one solution, okay? Because cos x, if it's half, it's positive. So it's positive in 2 of our quadrants. Okay, I'm just going to scroll down to the next page so I've got some more room. Okay, so then we just have all of our solutions, and what we want to do is order them. So we're thinking about, oh, actually don't need this much room because we're nearly done. X, therefore, is equal to pi on 3 times pi on 2, not times, pi on 2, 3 pi on 2, and 5 pi on 3. And that brings us to the end of that question. Now with this question, that's all we have to do because all we're doing is finding solutions, right? These solutions don't have like any, I guess, like value attached to them. Like they're not tides, they're not times, they're not sunlight, they're not anything. All we're doing is finding solutions. So that's why we can just leave those in terms of x. So again, with this sort of question type, super important question to come up. So this one's from the 2014 HSC paper. But even if you look like through the most recent HSC papers, you'll see at least one question somewhere that's about solving a trigonometric equation. So yeah, super common question type. And again, if you know how to approach it, and you know like the methods and the steps that you need to be remembering, then you'll be able to get these marks easily. Okay, well that was the